When you start learning a dense new subject, you often hit a wall of complexity. The sheer volume of information feels impossible to organize. Most of us respond by starting on page 1. We try to track every definition, every single rule, and every immediate exception as they appear in the text. This creates a heavy cognitive load. The brain is struggling because it's trying to hold on to 10 different pieces of data that have no clear relationship to one another. It is like trying to navigate a city by memorizing every individual street sign without knowing which continent the city is located on. The difference between struggling to learn and moving quickly often comes down to how much work you do to organize information before you start absorbing it. The first step requires a counterintuitive move. Ignore the details. You want to understand the foundational premise before you look at the granular facts. You need to identify why the concept exists and the specific problem it was built to solve. This creates a mental map. Every future detail now has a designated logical slot where it belongs. When you have a map, the work of learning changes. Instead of wondering where a new fact goes, you are simply filling in a blank space you've already prepared. Layering information prevents that initial sense of being overwhelmed. You start with the broad overview and move down into deeper levels of complexity. Take Selenium, a tool for web automation. It involves dozens of moving parts, but it becomes manageable when you break it into layers. At the highest level, Selenium is a bridge to a web browser. The next layer is the workflow, finding elements, performing actions, and checking results. Only then do you explore technical mechanics like WebDriver protocols or the page object model. Because these complex mechanics are attached to a structure you already understand, they feel lighter. You aren't trying to process them in a vacuum. A mental map also requires a filter. You have to evaluate new data by asking a single question: does this fit? When you encounter a new fact, you test it against the model you've already built to see if it aligns with what you know. If a fact contradicts your model, you look for the reason. Either your model was incomplete, or you found a unique exception. This keeps you engaged with the material. Sometimes, however, a concept is too abstract to fit into a logical map immediately. In those cases, an analogy provides a physical anchor. If you're learning about a software API, think of a waiter. You give the waiter an order, the waiter goes to the kitchen and brings back your food. The API is simply that communication layer. Once that physical image is established, the technical details of data requests and server responses have a recognizable structure to cling to. We often treat learning and memorization as the same goal. But long-term retention works better when you focus on making the information understandable first. The goal is to make the data memorable before you ever try to study it. Spatial visualization is a key tool here, especially for technical ideas like the 4 pillars of object-oriented programming. Imagine a building. Encapsulation is a locked vault, keeping things inside. Abstraction is the elevator. You use buttons without seeing the pulleys. Inheritance is a blueprint shared with a smaller building. Polymorphism is a control panel changing function based on who uses it. The brain finds it easier to recall one cohesive image of a building than 4 isolated abstract definitions. Learning is a cycle of mapping, layering, and visualizing. When the structure of the information is clear, memory follows as a natural consequence.